are times when I am not the most remembering type of person. Okay? So, we're going to start curve fitting today. Tomorrow is test day, remember. Okay? And so you have 2 worksheets out there for your benefit to make things go a little easier tomorrow. The one that's just the 4.4 worksheet A, okay, that's good and all, but your test looks exactly like the review worksheet, which was the one that you got yesterday. Okay, right? I mean, spit an image. 6 questions, all graphs. You got to throw in a vertical asymptote, or not a vertical asymptote, a vertical, the y-axis at some point in time in your graph, and then answer a couple 3 questions for each one. Okay? All right, so that's tomorrow. 2 mods, and that's all we're doing tomorrow is taking that calculus. So the faster you are at it, the more time you have to, sit and gaze out the window. Okay? Okay. Today, though, we're going to go to curve fitting. So we're going to do graphing, except now instead of giving the function at the start and the graph at the end of the problem, we're going to give you the graph at the beginning of the problem and ask you to go back and make the function at the end of the problem. So it's all of the same work, just now instead of going forward, we're going in reverse. Okay, so we're starting at the end, going back to the beginning. Okay? So if I were to have I want to make this a little bigger. If I were to have a function oops. Oh well. Nope, can't do it. Can't do it. Oh, much better. Okay? So if I were to have a function, okay, I'd have some different parts going on with it. Okay? So first off, I would need to figure out that this distance from the high to the middle, or from the middle to the low, this distance here is the amplitude. Okay? That those distances there are the amplitude. If I'm dealing with a sine function, then my start, I'll call them A's. So I could start there, I could start there, or I could start there. All of those would be starting points for the sine function, because sine starts in the middle. If it's a cosine function, I would start either at the top or at the bottom. When I get back to that spot, if I started in the middle, when I get back to, I skip over, when I start in the middle, I got to get to the second middle. If I start at the top, I got to get back to the top. If I start on the bottom, I got to get back to the bottom. Okay? But that distance is my period. And with the period, remember that is equal to 2 pi divided by the absolute value of b. And we want, our goal today is to get either a sine or a cosine function And that sine or cosine function is going to look like y equals a times the sine or cosine there of b times the quantity x minus c plus d. So it's going to look like that. So we need to use amplitude is a. So we got to find the amplitude. Period is b, or period comes from b. Start is c. Middle is d. All those things come through. Okay? So on the sheet that you should have gotten when you came into the room today, we have the first one for you. It's on top. I want to find a sine curve for the graph. Okay? Well, so the first thing that I am going to do is I am going to ask myself, how high up, what is the high point of this function? What is the maximum value of this function? -4. It happens up here and it happens right there. So the high value is -4. What is the low value of this curve? -16. Happens there, there, and there. Okay? If I know the high and I know the low, do I know the middle? -10, the average of the two. -4 plus -16 is -20. Divided by 2 is -10. So the middle of my function is at -10. Now, knowing that the middle of my function is here at -10, do I know my amplitude? What is it, Mark? 6, because it's 6 from the middle, which we just found, to the high, and 6 from the middle to the low. Yep. Okay. So my amplitude is 6. Because we're dealing with a sine function begins in the middle, correct? So I need to pick a middle point. For instance, right there at x equals -1. For sine functions, it's when we get back to the second middle, right? Because we go up, then we go down, and then we end at the back at the middle. So my end, I would skip that one, and my end would be right there, which is at 11. Right? Which makes then my period be how much? My period then is 12. Now, the period being 12 is important because the period is equal to 2 pi divided by b. And so if my period is 12, what's b? Remember, in math, we can flip-flop those two. As long as one's on top and one's on the bottom, then that leaves us with b is equal to 2 pi over 12, or b is equal to pi over 6. Right? Now, we're making a sine curve, so I need a. Have we found a? What is it? 6. It's the amplitude. We need B. Have we found B? Pi over 6. We found it over here. C. We need C. Have we found it? -1. It's this one right here. D. We need D. Have we found it? -10. It's the middle, right? So we found everything that we need to make ourselves have or write out a sine curve. So our sine curve is going to be A. We said A was 6. Sine of B. We said B was pi over 6. X minus C. C we said was -1. So this really becomes X plus 1. Double close. Plus D. D we said was -10. There, ladies and gentlemen, is a sine curve that fits this graph. What if, instead of starting here at -1, what if I said, let's start at 11? What changes in my function? The C value changes. A stays the same. B stays the same. D stays the same. The only thing that changes is my C value. So this I could have said, or 6 times the sine of pi over 6 times x minus 11 minus 10. Those two functions give me the same graph. Or I could have said 6 sine pi over 6 x minus 23 minus 10. All three of those functions give me the exact same thing. Right? It's just a matter of where you start. Or I could have said 6 sine of pi over 6 x plus 13. Then minus 10. Just that C value changes. And the difference in that C value is 12. Now, let's blow some minds. Could have I also started this function right there in the red circle? Because that's at the middle too, right? What changes if I start it there? Come on. Sorry, my pen was all of a sudden the smartboard stopped. Whoops, see? Smartboard stopped. What changes if I start at the red circle? What? No, I'm still starting in the middle. So it's still a sine. So it goes. So what needs to change? If negative A, okay, that's one change that could happen. The other change is the C changes to minus 5, right? But we'll do that, okay? So I could put a negative A value and start in the middle and go down, right? What's the other change that could happen? I could have a negative B value here. But then my A would have to be positive. And then I could change those, right? Instead of minus 5, I could go out to no, this one right here. I could go here. I could go to 17, right? I could go minus 17 there. Or I could go backwards here to, what would it be, negative 7 over here. So it would be plus 7 for my C value. Okay? So we could, so when you find 1, you found a lot. Okay? You found an infinite amount of them. Okay? Easy for you, hard for me. Because I got to know them all. You only got to know one of them. Okay? I got to know them all. Okay? Okay? What I would like you to do now is I would like you to find me a cosine curve off of the second one. All right, let's talk high first. What's the maximum of this function? 7. What's the low of this function? Negative 3. Where's the middle of this function? 2. Okay? So in there, that means that this is my D value. So at the end, it should be plus 2 on everybody's. Okay? See what you did, ER? Okay? All right? Then, amplitude is going to be the distance middle high, middle low. What's the amplitude here? 5. Middle up, middle low. It's 10 total, okay? But we just want middle to the top, middle to the bottom, so that's 5. That's my A value. So all of ours should start with 5. Or or negative 5 if we want a negative one. We'll show you that in a minute. Okay? Begins. If I start here, cosine starts on high. Okay? So that would be my start at negative 2. Come on, smart board. If I start at negative 2, oops, I'm going to move this D. If I start at negative 2, then I would end at 6, which means my period is 8. Period equals 2 pi over b. 8 equals 2 pi over b. So b then is pi over 4. C value is here. Okay? So the most common one that I saw when I was walking around the room was 5 cosine pi over 4 times x minus negative 2, because my beginning is at negative 2, so minus negative 2 means plus 2, and then plus 2. Okay? A couple of people I asked to find some different ones. The only thing that would change would be that number there. So instead of plus 2, it could be, oops, not plus 6. It would be minus 6. Could be minus 14. Could be minus 22. That's a fail. That's a hard fail right there. Could be plus 10. Could be plus 18, etc., 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 if we went the other way. Okay? Now, if I wanted to start down here, then I would have negative 5 cosine of pi over 4 x. Now it would be minus 2, and then still plus 2 at the end there. And I could change that one by changing this number to minus 10, minus 18, plus 6, plus 14. All of those would work in there. Okay? Questions on that? Flippity floppity. Let's talk some graphing. Okay? So, throughout the day, the depth of the water at the end of a dock varies with the tides. Page blocked? How can it be page blocked? I watched it already once today. There we go. Now, so the tides go in and come out as the moon gets closer and closer and closer to the Earth. Okay? So they go in and out on a sinusoidal pattern. So if you're watching, if you're sitting by the beach or sitting by any large body of water, you will see that this tide is still coming. Now you can see the dock rising up. This is a pretty extreme tide. I went to this one spot and we were going to have lunch, and the people at this place were like, if you're going to go walk over to that island, because there was an earth bridge over to this other island kind of a thing, if you're going to go over to the island and explore on that, do it before lunch. And we're like, well, why? And they said, because after lunch the tide will be in and you won't be able to get back. And we don't have any way to get you over or back from over there, because there was no docks or anything over there, so they didn't have anything to come and get us with. So sure enough, we went and we ate lunch. We didn't go over there. We went in and we ate lunch, and then we walked back out to this like viewing area, and the tide had come in, and it was completely like you couldn't pass. You would have had to either gone swimming or gotten a boat. It was so deep already. So it's pretty cool to see that stuff in action. Okay? So this table shows the depths of waters in meters at various times during the morning. Okay? High tide is at 4 a.m. and low tide is at 10 a.m. Why is those two important? Why is high tide, knowing when high tide is, why is that important? And knowing when low tide is, why is that important? We'll take high tide for example, because it'll work for low tide also. What does high tide mean? So what does high tide mean then? The highest point of the water, right? Which means the water is the deepest, right? So that's going to be the maximum on our graph, right? Okay, so that's the high tide is going to be the maximum of our graph. It's going to be the high point on our graph. Low tide is when the water is the lowest or shallowest, okay? Which means that's going to be the low part on our graph. Okay? So what I would like us to do now is I would like us to graph these data points on a scatter plot. So you're going to need a graphing calculator, and I would like it if you're using one of ours, go to a brand new document. Don't go to a sketch pad, go to a brand new document. Okay? So how we get there, you double tap the on button. Once to turn it on, once to get to this page. Then you're going to go to new document, and you're not going to save whatever's on there. Don't save it. Okay? We need to put in some data, so we're going to go into lists and spreadsheets. We're going to have to title our columns. What do you think the first title should be? Time. Let's do time. I love it. Okay? Now, before we start inputting time, what's the problem with a 12-hour clock? It repeats itself, right? So how can we avoid repeating itself? Go to a 24-hour clock. On a 24-hour clock, what is midnight? It is 0 hours. Midnight is 0. So 12 a.m. is midnight. That is actually 0 hours. Then the next one is 2 and 4 and 6 and 8 and 10 and 12. Then we need to go over what do we need to put in for our second column? Depth. .55, 3.80, 4.40, 3.80, 2.55, 1.80, and 2.27. Make sure you hit enter after your last one so that you are not, so that it has put it in there and put it all in there and make it all nice and pretty. All right? Good? Now, refresh my memory. How to make a scatter plot. Menu, not yet. Do I have to make a new page first? Data and statistics. Horizontally, I want it to be, what do I want on my horizontal? Time. Vertically, what do I want it to be? The other one, depth. Oh, does that look sinusoidal to you? That looks sinusoidal to me. Okay. Now, one thing that you can do from here is you can make yourself a sinusoidal regression equation. You can analyze this function and you can make a regression and it will show you the sinusoidal one. Okay? That's what we're trying to get to. Okay? But that's the calculator doing all the work for you. Okay? Now, let's do it ourselves. Okay? Let's get that exact same thing from ourselves. So, what I want to do, because I want to be able to manipulate some of this stuff, I want you to open a new page. And on that page, we're going to just make our own graph. So a new graphing page. We're going to go into Menu, Entry and Edit, Scatter Plot. The X value will be time. The Y value will be depth, or whatever you titled your columns. Then when I hit enter, I see that. Yes? Okay. Now, a couple of things. One, do I need negative X values? What is negative X values in this particular scenario? Negative time, X values would be negative time, which would be yesterday, right? So I don't need those. Do I need negative Y values? What does that mean? Negative depth, right? So the water underneath the soil. So I don't need any of those. So let's go into Window and Zoom. Let's adjust our window settings. We don't need X minimum, or we don't need negatives, right? But I like to see my axes, so I'm going to go to -2. How far out should I go? How far? So we're only going to 5 a.m.? let's go out to 25. And let's go a scale of ones, because that'll help us out. Okay? That'll help us out. Y's now. Minimum Y's. 0, right? But I like to go a little bit below that because I like to be able to see my axes. Oops, I doubled the negative there. Maximum Y value was 5, right? Or 4.4. So let's just go up to 6 because that'll give us enough. And then let's go by ones there again. I'm going to move my time and depth aspect of it. Okay.
That one, and I want to go that one, and there. Okay.
So, my question to you is this. Where is my high point? 4.4, right? Okay, so this is my high at 4.4. Where is my low? 1.8. This is my low at 1.8. So based upon that, where is my middle? Where's the middle? How'd you get 3.1, Lucas? Add them and divide by 2, right? Right? 4.4 plus 1.8 is 6.2. Divided by 2 is 3.1. I would agree that our middle is at 3.1. That's our D value, correct? Can I get A value now? What's my A value? What do you got, Scrick? 1.3. The distance from 3.1 up to 4.4, or the distance from 3.1 down to 1.8 is 1.3. That's my A value, my amplitude. Okay? Now, logic question for you. In a sine curve, so in a sine curve or even in a cosine curve, horizontally, if I go from the high point to the low point, how much of the curve have I gone horizontally, high to low? What? Half of it, right? I have gone half of it. Because that high point in the sine curve is the halfway point between the first quarter and the second quarter. And then breaks it up into quarters, right? Okay. So if this distance here is half of the curve, that means that this distance here, oops, I went too far. I went to 4. That means that this distance here is half the curve, right? Well, horizontally, what is that distance? 6 hours, right? So my period then is how long? My period is 12 hours long, which means my B value is going to be what? Pi over 6. If my period is pi over, or excuse me, if my period is 12 hours long, the distance from my high point here to my middle point there is how much? If my period is 12, what's the first quarter distance? 3, right? So where does this curve start? It starts at, does not start at 0. It starts at 1. Because the high was at 4, a quarter of the period gets me from the high in a sine curve back to the beginning, right? Alright, so it gets me back to the middle. So 3 hours backwards gets me to 1 o'clock. Do we have enough information now to make a sine curve? Yeah. Okay. So my sine curve would be y equals A, which was 1.3, times the sine of pi over 6, x minus 1, because we started at positive 1 hour, or at 1 a.m., plus 3.1. What if I wanted to make a cosine curve out of this? Y equals, would my amplitude be the same? Yes, 1.3 cosine. Would my period be the same? Yes. Where would I start, however? I'd be starting at 4, right? Agree? Nope. D is the middle. Always. Okay, I'll show you. Let's go to the graph, because now we can manipulate the graph. So I'm going to go back into just a regular old function, and we said that it was 1.3 times the sine of pi divided by 6 times x minus 1, then plus 3.1. Yes? Okay. Or we said it was 1.3 cosine of pi divided by 6 times x minus 4, x minus 4, then plus 3.1. Puts it right over the top of it. Okay? Which, if we go back and we look at my regression equation here, 1.3 sine of, that's pi over 6. That's 1 times pi over 6 plus 3.1. Okay? Now, my question to you is this. Oops. Gotta get rid of those. Hopefully I can just erase them. My question to you is this. The next two questions were, find the depth at 9 a.m. and 3 p.m. Well, you've got two options. One, you could figure out what 9 a.m. is and stick it into our function. Right? So we could go here and we could say, oops, I didn't start a calculator page. What is f sub 1 of 9? And the depth at 9 a.m. is 1.97. What is the depth at 3 o'clock? So what am I going to put into my function for 3 p.m.? I'm going to put in 15 because remember I'm on the 24-hour clock. So the depth at 15 hours is 4.22. Okay? Now, on my graph, the other thing that I can do is I can use what's called the trace. And if I set my trace step to 1, that's going to give me every hour. Oops, this one. On trace. Graph trace. So now at 12 hours, it's at 2.27, which we set. But we want to go at, oops, why does it skip over 9? Oh, because I'm on the wrong, that's why. There you go. Now I'm on my blue function. 9, 1.97. Okay. 15, 4.23. Just like the function had. So you got 2 options there. Look at, listen, it's Mrs. Lensmeyer.
Just a reminder that the One Warrior Nation will meet today after.
Go with it.
I still don't get why it starts at 1.
At 1? Because this is not my middle. Okay? So my middle we said was 3.1, right?
Yeah.
Okay? So if I put in here, if I put in 3.1, that's where my middle is, right? Sine curves start at the middle. This right here is not at the middle. The intersection of red and black is not at the middle. Or it's not, it is the middle, it's not at 0. Okay? You know what I mean?
Yep. You do that in your head?
Did I do what? The 1? No, I figured out the 1 part from, no, underneath here. I figured out the 1 part from the fact that our period was 12. Okay? So that means if my period is 12, that means the distance from high to middle is 3, because that's a quarter of my curve. Okay? So if it was 4 o'clock where the high was, 4 a.m., back 3 hours is 1 o'clock. Yep.